This is Algebra Lesson 8.3, Fitting Exponential Models to Data. So, all of our situations so far with exponential equations has had a constant ratio. It's always been 1.5, 1.5, 1.5, 1.5. Or it's always been take away 12%, take away 12%, take away 12%. So this is the first situation where it's not going to be exact. There's an investigation here if you would like to explore. This investigation is extra credit. So if you don't do it, you're not going to lose any points. If you would like to do it, head to the store, pick up a bag of M&Ms, go through the steps, and that is worth extra credit. The big idea, if you don't do it, is that when we have a bunch of varying ratios, we end up using the average ratio in place of our change in our equation. So what I mean is, if in this investigation, say I started with 70 M&Ms, and then after doing my equation or my experiment steps a couple times, I ended up with maybe 58 M&Ms, and then maybe 42, and then maybe 30, and then maybe 29, and so on and so on. If I calculate all of these average ratios, or if I calculate all of these ratios, I'm not going to get the same every single time. I have a ratio as low as 0.71, a ratio as high as 0.97. But, assuming I kept going all the way down the list, I can get the average of these ratios, and I'll just use the 4 I have right now. And right now, my average is 0.81. So I could write an exponential model for this situation starting at 70 and changing by going down 0.81. So that's the idea. When you have a bunch of ratios that aren't the same, use the average. Okay. There aren't really any other notes other than that, so good luck on the exercises, and let me know if you have any questions.